Okay, let's start for the presentation. Before we start, I to open the presentation first. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi
Waalaikumsalam
wabarakatuh.
warahmatullahi wabarakatuh.
Okay, thank you. For tonight, we're gonna present about inference, the statistic in educational research from foundation concept and the correlation analysis. This is the first BAP and the second BAP. So let's start. Before we start, let me introduce our group first. So my name is Hafiz Azari, and another my teammate, my group.
My name is Rifki Pratama.
My name is Nurani Safitri.
My name is Selvi.
My name is Dewi.
Okay.
Isinta Nuraini.
Okay. Thank you. So let's go and start the presentation from the first BAP and second BAP. For Dewi Wijay Putri, the presentation starts now.
Okay, thank you. Chapter 1, Introduction and Basic Concept. In Chapter 1, we start with the history of statistics. The word statistic comes from terms meaning stats. It has been used since ancient civilization like Babylonian, Egyptian, and Roman eras from census records. The term was introduced by Gottfried Eisenhower in 1749. Okay, next. Classification of statistics. Statistic is divided into descriptive and inferential. Descriptive statistics present data using mean, median, and graphs. Inferential statistics make general conclusions from a sample to a population. It can be parametric for normal data and non-parametric for non-normal data. Okay, next. Characteristic and function. Statistic has three main characteristics. It is quantitative, objective, and universal. Its main function is to have decision making based on measurable data. It is widely used in education, management, banking, and other science. Okay, next. Role of statistics in research. Statistics is important in every stage of research. It helps determine sampling technique, test validity and reliability, visualize data, and test hypotheses through comparative or correlational analysis. Okay, let's move on to chapter 2. Correlational analysis. Introduction to correlational analysis. Chapter 2 discuss correlational analysis. Correlation means a relationship between variables. Its objective is to identify whether a relationship exists and to determine its direction and strength. There are symmetrical, causal, and interactive relationships. Okay, next. Next. Variables and relationship cycles. In correlational research, we have independent variable, which influence, and dependent variable, which is influenced. Based on the number of variables, correlation can be bivariate, meaning on X and one way, or multivariate, meaning more than one X influencing one way. Okay, next. Correlation index and direction. The correlation coefficient symbolized as R range from -1 and +1. Positive means both variables increase together. Negative means one increase while the other decreases. Zero means there is no relationship at all. Okay, next. Visualizing data scatter plot. Scatter plots are used to visually represent data points on x and y axis. If the points from a straight line, it is linear. If they from a curve, it is nonlinear. This help researchers see potential correlation before calculation. Okay, next. Choosing the right correlation technique. The choice of correlation technique depends on the level of measurement or data type. Different scales such as nominal, ordinal, interval, or ratio require different statistical formulas. Okay, next. Conclusion. In conclusion, statistics is not just about numbers but an objective tool for solving problems. Understanding correlation helps researchers predict relationships. For example, how motivation affects academic achievement. Okay, maybe next chapter by my friends.
Okay, I will explain about product moment correlation, also known as Pearson correlation. This method was developed by a corporation. It is used to measure the relationship between two variables. To use this method, the data must meet several requirements. First, the data must be in interval or ratio scale. Second, the data must be normally disturbed. Third, the data must be homogeneous. Okay, and introduction and purpose. What is it? For the first, developed by Carl Person, often called Pearsonian correlation. And second, used to test associative hypothesis relationship between two variables. And data requirement. For the first, data must be interval or ratio scale. And second, data source must be homogeneous equivariance. And the third, data must be normally distributed. And key assumption. For the first, it's only measure linear relationship. And the second, if the relationship is not linear, the analysis might incorrectly show no correlation. Next. Correlation index R and coefficient of determination R2. Correlation index R XY, a value representing the strength and direction of the relationship. Formula R XY, Fred's sigma EX, SQRT sigma X, 2 sigma Y2. Coefficient of determination R2. Formula R2 RXY 2 times 100%. Purpose. Measure the percentage of influence the independent variable X has on the dependent variable Y and X. Interpreting the correlation R values best present as a table. Between 1,000,020 very weak, consider no correlation, and 021, 040 weak correlation, 041 and 070 moderate correlation, 071, 050 strong correlation, 0.51 and 1.00, very strong correlation. Next, hypothesis testing. How do we know if the relationship is statistically significant? 1. Method 1. Comparing R calculate RH with R table RT. If RH RT HO is rejected, right zero correlation is significant. If RH RT HO is accepted, right zero correlation is not significant. And the second, degrees of freedom. The F calculate as n -2. And the third, significant levels. Usually test at 1% or 5% error margins. Next, SPSS analysis workflow. For the for the first, define variable. Enter variable names, advertising, choice versus sales turnover in variable view. For the second, data entry. Input the raw data into data view. Third, run analysis. Click analyze to correlate to evaluate. For the four, select method, choose person and to tailor significance. And the last, interpret output, analyze the person correlation value and the site to tailored value. Okay, next. Case study example. For the one case, relationship between advertising cost and sales turnover. And the second result are a 0.941 very strong positive correlation. And the third finding as advertising choose increase, sales turnover also increases significantly. For the fourth, contribution R2. 55% advertising choose account for 55% of the change is in sales. Okay, next.
Okay, next we want to talk about chapter 5, analysis procedure of Kendall-Tau. So, Kendall-Tau correlation is a non-parametric statistical test. It is mainly used for ordinal or ranking data. This means the data are arranged in order, such as rank first, rank second, and rank third. Levels like low, medium, and high. The main purpose of Kendall-Tau correlation is to determine the relationship between two variables based on the rank. We usually use Kendall-Tau when the data are not normally distributed, the data are in ranking form, parametric tests like Pearson correlation cannot be applied. So, Kendall-Tau is a good alternative when parametric assumptions are not met. Next, we gonna discuss about analysis Kendall-Tau correlation using SPSS. First, data preparation. We need to prepare the data, make sure the variables are ordinal or continuous. We input the data in variable view to define the variable name, type, and measurement. Second, data view to enter the actual data. This step is important because incorrect data setup can affect the analysis result. Analysis step in SPS. After the data are ready, the next step is analysis. The steps are click analyze, choose correlate, and click bivariate. This menu is to test the relationship between variables. Third setting, in the correlation option, select Kendall-Tau -B, uncheck Pearson correlation, choose two-tiled significance. Two-tiled significance is used when we do not specify the direction of the relationship. Fourth, output interpretation. After running the analysis, SPSS will show the output. There are two important parts. First, the correlation coefficient. The value ranges from -1 to +1. A value close to 0 means there is no relationship. A value close to +1 means a strong positive relationship. A value close to -1 means a strong negative relationship. Second, the significant value or P minus value. If P 0.05, the relationship is statistically significant. If P 0.405, the relationship is not significant. Next, we're going to discuss about the chapter 6 analysis procedure of P correlation. Okay, the basic concept of P correlation. Next, P correlation is also a non-parametric correlation technique. However, it is used in a different situation. P correlation is applied when both variables are dichotomous, which means they have only two categories. Examples include yes or no, pass or fail, male or female. This technique is commonly used in educational research to examine the relationship between categorical variables. Next. Okay, now we'll talk about data arrangement and contingency table. P correlation uses P correlation uses 2 equal to contingency table. Raw data are organized into 4 cells. Cells A, X equal 1 and Y equal 1. Cell B, X equal 1 and Y equal 0. Cell C, X equal 1, X equal 0 and Y equal 1. Cell D, X equal 0 and Y equal 0. This table helps us see how the two variables are distributed and related. The P coefficient is calculated using the frequency from the 4 cells A, B, C, and D. The formula combines these values to show the strength and direction of the relationship between the two variables. Next. Okay, now we talk about significant testing, inferential analysis. In significant testing, we start by formulating hypothesis. HO, null hypothesis, there is no relationship between the variables. H1, alternative hypothesis, there is a significant relationship between the variables. P correlation is closely related to the chi-square test. The calculated value is compared with critical value at the chosen significant level, such as 0.05 or 0.01. Next. Okay, we talk about interpretation of results. The P coefficient also range from -1 to +1. If the calculated value exceeds the critical value, the null hypothesis is rejected. This means there is a significant relationship between the two dichotomous variables. So to conclude, Kendall-Tau correlation is used for ordinal or ranking data. Meanwhile, the P correlation is used for dichotomous data. Both techniques are useful when parametric assumptions are not met. That's all.
Okay, next I will be continuing chapter 7, contingency correlation analysis technique. Next. Next. Okay, so simply this is a statistical tool we use to find out there is a relationship between two variables when our data is the form of categorized. For example, grouping people based on their enthusiasm for exercise, such as high, medium, or low. The best part about this technique is that it is a non-parametric statistic, which means we don't have worry about whether our data follow a normal distribution or not. Next. Okay, the core formulas. To find the correlation value, we use the C-index formula. As you can see on the screen, C equals the square tools. C equals the square root of C squared divided by N plus C squared. It might look a bit complicated, but the main key here is the C squared value. We get this C squared value by comparing frequency observed, which is the observed frequency from our actual data with frequency theoretical. The theoretical frequency, basically, we are just measuring how far the reality differs from our expected theory. Next. Okay. Now is hypothesis formulation, P transformation. Before we calculate anything, we must set our hypothesis, null hypothesis, or C equals 0, meaning there is no correlation between the variables. Conversely, states at alternative hypothesis state that there is significant correlation. Once we calculate the C value using the previous formula, we need to convert it into a P value, or P equals C. Using this formula shown on the slide, this P value is what we will ultimately use to draw our final conclusion by comparing it to a standard statistical table. Next. Okay, next, this is the calculation table that you can see that the example of the table here. So to give you a clear picture, let's look at the simulation. So that's table 7.3. Show a study on the relationship between exercise enthusiasm and work spirit. The collected data is put into these grid boxes, which we call cells. Then we transfer this data to table at 7.4 to calculate the differences. So you don't need to stress over the exact number because that main point here is just a tool to sum everything. At the bottom right corner, we finally get our total C squared value, which is 18.7134. We will then plug this number into our main formulas. Next. So this, the final calculation. The final calculation finding C, with final stages of our calculation, if you recall from the previous table has been given before, we found our total C squared value to be 18.70,134. Now we bring that number back to our very first formula by flagging the number into the contingency coefficient formula or the C formula. We get a result of approximately 0.29255. But we don't stop there. In statistics, the C value alone is a bit tricky to interpret directly from standard table. Therefore, we have to transform the C value into a P level. Represented by the symbol P, we use the formula P equals C divided by the square root of 1 minus C, like at the example of the picture. After doing the math, our final calculated p-value is 0.306. So we should to keep the number in mind because this is the key to answering our entire research question. Next. Okay, now the hypothesis testing and interpretation. At the hypothesis testing and interpretation, we have the number. So what does it actually mean in the real world? The books provides two ways to interpret this number. The first one is the simple interpretation. If we look at the standard correlation benchmark, the value 0.306 falls into the 0.21 to 0.40 bracket. This simple means that there is a weak but positive correlation between the two variables. However, as researcher, we need to be more scientifically be clear. This brings us to the second method, hypothesis testing. So to do this, we must compare our calculated P with the standardized table P. First, we should determine our degree of freedom or DB, which is n minus 2. Since we have 200 respondents, our degree of freedom is 198. If we check the statistical table at 5% at the picture, we have the final conclusion. So it means we have scientifically proven that there is a significant positive correlation between exercise enthusiasm and work spirit. Next. Okay. Next, it's next slide. Okay. Next slide is about the hypothesis testing. So I think this is the same. Okay, this alternative shortcut direct C square. Now we move to the chapter 8, point biserial correlation analysis techniques. Same like at the chapter 7, this also use biserial correlation analysis, also used for finding relationship between general categories. This capture is highly specific and extremely useful for us as the future educator. What is the main purpose? We use it for item validity testing. So for example, imagine you create an English. So this parametric used for how do you know if the question number 1 till question number 50 is the actually good a good question. So if we just confusing the student, this is where point biserial comes in. It helps us evaluate test quality by correlation to different types of data, which is whether the student answer is correct or incorrect, and continuous data, which is the student overall test score. In short, it's like a detective to spot bad question. So this used for validity our question test. Next. Next page. Okay, now I will continue the core formula and logic. At the formula and logic, so let's see the symbol and the formula here. To catch this bad question, we use the formula shown on the screen. It is read as R point serial equals mean of P minus mean total divided by standard mean minus mean total, deviation total, times the square root of P over Q. So at the symbol, the logic behind this formula is actually brilliant. It simply compares MV, especially mean data, which is the average test score of the student who answer this specific question correctly with MT. MT is mean that M data. The average score of entire class. This show how the overall question should get the formula detect to use this normal pattern. The question, is it valid or not? But if the top students are getting it wrong, while the lowest scoring students are getting it right, the formula will flag it, indicating that the question is misleading or flawed. Next. Next page. Okay, now this hypothesis and case study simulation. So just like any statistical test, we have our hypothesis for item validity. Our null hypothesis state that the question is invalid. The alternative hypothesis state that the question is valid. So if the result is a null hypothesis, it means that the question is invalid. But if the hypothesis used the alternative hypothesis states that the question is valid. The rule of thumb here is the absolute value of our calculate R must be greater than or equal to the table R. If it is, the question is safe to us. To make this concrete, let's look at the example on table 8.1. Here we have a simulation of 10 students labeled A to Z taking a 10 question test. Because the data is discrete, a secret answer is scored as 1 and an incorrect answer is 0. From this raw data, we want to figure out one thing. Is the question number 1 a good question or should we throw it away? So that's how we find that the question is valid to use for test or not. Okay, the next. Next page. Okay, now final calculation and the predict. After we get the data, is it valid? Is the question is valid for Okay, I will continue the last slide of our chapter at the chapter A. So this have 3 steps. So after we got the number, we got the answer, we isolate the data just for question number 1 and plug it into our point serial formula. As you can see at the bottom of page 74, our final calculate result is 0.230. Is it good enough? So let's check the statistical table. Our degree of freedom is n-2, which gives us 8. Looking at the table with a standard 5% margin of error. The minimum threshold we need to pass is 0.632. So here is our final predict. Because our calculate value of 0.230 is strictly smaller than the required of the data, that's it 0.632, we must excessive to null hypothesis. Okay, so that's how the point biserial correlation help us maintain the quality of our educational educational assessment. Thank you so much for your attention. Next.
Okay, in chapter 9, slide 1, what is multivariate correlation? On this slide, I explain about multivariate correlation. Multivariate correlation is a statistical method used to analyze the relationship between several independent variables and one dependent variables the same time. This means we study how multiple vectors together are related to one outcome. Next. Relationship between independent and dependent variables. So in research, there are two types of variables, independent variables and dependent variables. Independent variables are the factors that influence an outcomes. Dependent variables is the result that is influenced by those factors. The purpose of correlation analysis is to measure how strong the relationship is between the independent variables and dependent variables. Next. Types of multivariate correlation. There are different types of multivariate correlation. The most common types is multivariate correlation. Multivariate correlation is used to explain how several independent variables together relate to one dependent variables. Next. Explanation. So in the slide 4 is this slide explain the symbol used in multivariate correlation. One symbol present the relationship between the first independent variables and the dependent variables. Another symbol represents the relationship between the second dependent variables and the dependent variables. Another symbols show the relationship between the two independent variables. The final symbols represents the combined relationship of both independent variables with the independent variables. So this symbol helps you understand the strength of the relationship. Next. Example of variables. In the research examples, the dependent variables is organizational effectives. The first independent variables is student learning motivation. The second independent variables is communication fluency. And the data were collated from a group of response to analyze the relationship among those variables. Last. Next. Interpretation of the correlation result. The result so the learning motivation is related to organizational effectiveness. Communication is also related to organizational effectiveness. However, the relationship between learning, motivation, and communication is not very strong. Maybe that's all for me.
Okay. Now I will present about the regression and comparison analysis. So let's move to an introduction. So tonight I will show about the regression analysis, comparative analysis, and used to analyze the numerical data. So let's get started. Though for the first is the regression analysis. So what is this? The regression analysis? Regression analysis is a statistical technique to examine the effect of one variable on another. When is it used to the regression analysis? When the researcher wants to the test influence to predict the outcomes. Like example, relationship between the study time or the X and the test score or the Y. And next, let's move to the hypothesis and interpretation. So hypothesis, the X is like the example have the H0, X has no effect on Y. But if the H1, the X affects Y. That is the hypothesis. So for the interpretation, if the coefficient be not the same as the 0, so that it means like the X has an influence on Y. So let's move to the last chapter is the comparational analysis technique. So introduction to a comparative analysis. So what is it? The comparative analysis, a statistical method to compare two or more groups, like for the purpose to identify whether the difference between groups are significant. So the key of the comparative analysis is the groups. For the example, comparison of learning outcomes. For the first, like the online class, and the second is face-to-face class. Let's move to the main techniques in comparative analysis. So there are two groups. For the first is the t-test, and more than two groups is ANOVA. So the use to the these two is the test mean the difference and supports research hypothesis. So this is the core formula comparative analysis. So this is the core of the formula. This is the hypothesis that I mentioned, and this is the interpretation. The first is the that I said is the hypothesis, and the second is the interpretation. So for the conclusion, regressions more focus on the relationship and the influence, comparative more focus on the group difference. So they have the other focus for the regressions that explains the effects, comparative analysis explain the difference. Both are essential in quantitative research. So I think that's all from me. So let's move to the question and answer from for the audience. Have you have any question?
Yes, I have question.
Okay, thank you. So what's your name and what's group for and what's the question?
Okay, my name is Saparina Hidayati. So my question is, when should a researcher use Kendall-Tau correlation instead of PHI correlation, and what type of data is required for each method? Is it clear, my question? Or repeat?
Yes, you can repeat the question.
Okay, wait. So when should a researcher use Kendall-Tau correlation instead of PHI correlation, and what type of data is required for each method?
Okay, Nana, thank you for the question. Next.
Okay.
You
Next
guys,
question, please.
you guys have any question? The audience?
Yes, I have a question.
Okay, thank you. What's group and what's your name and what's the question?
My name is Fatan, and my question is, why does Pearson correlation only measure linear relationships? Do you get my question?
Yes, Batan, thank you so much for the question.
Okay, any question?
Okay, I will answer the Safarina question first. A research should use candle-tau correlation when the data are ordinal or in the form of ranking, such as low, medium, high, or rank order, especially when parametric assumptions are not met. On the other hand, p-correlation should be used when both variables are dichotomous, meaning they have only two categories, such as yes or no, pass or fail, or male or female. Do you understand, Sabrina Hidayanti?
Yes, Miss, I understand. Thank you.
You're welcome.
Okay, I want to answer Fatan question. Your question is, why does person correlation only measure linear relationship? The answer is person correlation is designed to measure the strength of a straight line relationship between two variables. It calculates how closely the data point follow a linear pattern. If the relationship from a curve or another non-linear pattern, person correlation may give a low value even though the variable are related. Do you understand what that?
Yes, thank you, Rifki.
Okay, maybe this is the for the closing. And before I will close the group, thank you for you guys for the attention, and thank you for the presenter to present the material. So let's close this meeting. Let's say hamdalah to all together.
Alhamdulillahirabbil
Alhamdulillah.
Alhamdulillahirabbil alamin.
Okay, thank you. So let's close this meeting. I'm Habis Anas as a moderator. To close the meeting. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam
Waalaikumsalam
warahmatullahi wabarakatuh.
warahmatullahi wabarakatuh.
Wabarakatuh.